pine cone of mass 15 grams falls from a tree branch which is 18 meter above the ground. So use the conservation of energy to determine the speed when it hits the ground. Okay, and we have to assume that obviously there's no energy loss. So the figure looks something like this. Is the ground. Hmm. And this is how the mass is falling from the top, and just about when it is supposed to hit the ground, it has some velocity v. This distance is 18 meters, and the mass is already given as 15 grams, so I'm representing it by m. So definitely when we conserve the energy, the initial energy, which is mgh, is equal to the initial energy, which is the only the gravitational potential is converted into complete kinetic, which is half mv square. So the m and m is cancelled, we are left with 2gh is equal to v square. So the value of v, just flipping the equation and taking square root both sides, is root of 2g h. So I mean, it's not dependent on mass like we are seeing it. So 2 times 9.8 times 18, and the square root of this value comes out as 18.78 meter per second. So this is the required velocity. If it actually hits the ground with a speed of 10 meter per second, and then how much energy was dissipated by air resistance? Okay, so then we have to calculate what was the initial energy. The initial energy, we're talking about part A, was mgh, right? So what is m? That is 15 over 1000, because we have to convert in kilograms. G is 9.8 and h is 18 meters. So this is coming as 15 times 9.8 times 18 over 1000, which is coming as 2.646 joules. This is the initial energy. And what is the final energy? The final energy is half mv square. So that's half times m, which is 15 over 1000. And we are already given the value of potential, that is v square. V square is what, 100, right? So these two are cancelled. So what are we left with is 15 over 20. So it is 0.75. 0.75 joules. So where is the remaining energy going? The remaining energy is actually lost in the form of heat. Lost in the form as an air resistance. So something which is being lost is 2.646 minus this value, which is 1.896 joules. 1.896 joules. So this is by how much the energy has been lost. And what is the average force of the air resistance? So the average force is going to be um, for that, we already know the value of the, what do you call it, the work done by the force, right? Because this is the work done by the air. So work done is what, f times displacement, right? And the displacement is same as the height. What is the height? Height is 18. So can we say that f times 18, which is the work done, is actually equal to 1.896? So this f, which is actually the average force which is being exerted by the air, will come out as 1.896 over 18. So this is the final answer, which is coming as 0.1053 Newton. This is the average force. Thank you.